Okay, ladies and gentlemen, today we're going to learn about position time graphs and velocity time graphs and how to read them. First off, what is a position time graph? Well, a position time graph shows an object's position at a particular time or during a particular set of times. So it basically shows the position of an object during a certain period of time. You can use position time graph to see how an object is moving. You can also use it to figure out what the velocity of the object is, or basically how fast the object is going. So this is a position time graph, and here are the rules that you need to know in order to know how to read it. If you follow these rules, you will know how to read one of these position time graphs, so make sure that you get all of the rules written down. First off, let's start with, believe it or not, we're going to start with Rule 5. The first thing you need to do when you're looking at a position time graph or a distance time graph is you need to make sure that you're actually looking at the right type of graph. Because later on we're going to talk about velocity time graphs. And so you need to make sure that you're actually looking at a distance time graph and not a velocity one. So here's how you can tell that you're looking at a distance time graph. If you look at the graph and on the left-hand side it says distance, or miles, or kilometers, or it has some sort of unit that indicates you're looking at distance, and you look at the bottom of the graph and you see that it says time, or it has some sort of unit that represents time, then you know for certain that you're looking at a distance time graph, and they're also called position time graphs, so either one, it's a synonym. Okay? So first look at the left side, make sure you've got a unit that says something about distance. Look at the bottom, make sure you got a unit that says something about time. So that's rule number 5. That's how you can tell that you're looking at the right type of graph. Now, once you know for certain that you're looking at a distance time graph or a position time graph, again, they're the same thing, then you can follow these other 4 rules for knowing how to read it. Guys, on Ames, they will try to mess with you. They will give you a graph and ask you questions about the graph and have answers. And they may give you a velocity time graph and then give you a distance time graph answer. And you could circle the wrong answer if you're not absolutely sure that you're looking at the right type of graph. So again, make sure, check the side, check the bottom, make sure it actually is a distance time graph before you start reading it and answering the questions. So what are the rules for reading this thing? It's pretty simple. Going up here, you've got the distance. 0 is the origin, so that's where the object started. Okay, and then going up here, we're looking at miles. So this is 20 miles, 40 miles, 60 miles, 80 miles. So when you read this graph, you can say, okay, after one, and going down here, this is the time. So this is a half hour, 1 hour, 1.5 hours, 2 hours. So you can say here that at 1 hour, so at the 1 hour mark, the position of this car was 60 miles away from its origin. So after 1 hour, the car was 60 miles away from its origin. And the way you read that is you go to 1 hour, you go up to the graph, you go over, and you see it's at 60 miles. So that's the first thing. Other than that, though, you can follow these 4 rules. Number 1, if the graph is going up, that means the object is moving forward or it's moving away from the origin. So this car right here, the graph is going up. That means this car is moving away from the origin or it's going forward. Here, the graph also is going up. So that means that the car is moving away from the origin. Okay? It does not mean the car is going up. Okay, so don't get confused. Just because the graph is going up, it doesn't mean that the object is going up. It means it's moving forward or away from the origin. Number 2, this graph doesn't do it, but if this graph right here suddenly started going down, that would mean that it was moving back towards the origin or going backward. So when the graph is going up, it's going forward or away from the origin. When the graph is going down, it means it's going backward or back to the origin. Number 3, if you have the graph and it's flat, it's got a straight line in a spot, that means that the object is not moving at all from this point to this point because it's flat. And finally, you can use the slope of this graph to figure out how fast the car is moving or its velocity. So for instance, between 0 and 1 hours, the car went from 0 to 60. That means if rise over run is the slope, so if you take how far it went up, 60, over the run is 1 hour. That means that this car was going on average 60 miles per hour during that first hour. Between 1 hour and 1.5 hours, this car, the slope here is 0. So that means it's going 0 miles per hour for that period of time. The car is stopped. That's also why the line is straight, because the car is stopped. And then between 1.5 hours and 2 hours, it goes from 60 up to 80 miles per hour, or 80 miles, sorry. So that means 80 minus 60 is 20 miles. It went 20 miles, and it did that in a half an hour. So that means from here to here, it was going 40 miles per hour. So again, when the graph goes up, it means the car is moving away from the origin, or the object going away from the origin. If the graph were to go down, it would mean it was moving towards the origin. It's going backward. If it's straight across, it means that the object is standing still. And you can take the slope between any 2 points to figure out how fast the car is going at that time, or what its velocity is. Now remember, guys, we said if an object was going back towards the origin, it would have a negative velocity. If you think about it here, that makes sense, because if we had a line here that went down, our slope would be negative. And so that would mean you had negative velocity and that the car is going back towards the origin. That's how you read a distance time graph. So looking at this graph, we're going to read this graph very quickly. From 0 to 1 hour, first of all, we're going to make sure it's a distance time graph. The title tells us it is, but over here we have kilometers, that's a distance unit. Down here we have time, that's an hourly unit. Then our time unit. Then from 0 to 20 kilometers here, from 0 to 1 hour, the graph is going up. That means the car is moving away from the origin. It's going forward. Then the graph is flat or straight. That means the car is standing still, or the object is sorry, in this case it's a boat. The boat is standing still. Then from here to here, the graph is going up again. That means the boat is moving away from the origin again. Here, the graph is flat. That means the boat is standing still. Here again, graph going up. The boat is moving away from the origin. Here, the graph is flat. The boat is standing still. And finally here, the graph is going up, which means that the boat is moving again away from the origin until we get to the end. Also, so here's our questions. How many stops does this boat make? Well, every time you have a flat or straight line, it means the boat's not moving. So that means it's stopped. So here we have 1, 2, 3 flat lines. That means it made 3 stops, or it stopped 3 times. What is the boat's average speed for the whole trip? Well, remember, we calculate the speed or the velocity by looking at the slope. So here's where the boat started, and here's where the boat ended at the end of the trip. So the boat went from 0 to 100 kilometers, so the 100 kilometers divided by the time was 10 hours. So it went 10 kilometers per hour on average for the whole trip. That does not mean it went 10 kilometers the whole time, per hour the whole time. For instance, right here between this spot and this spot, the boat went 20 kilometers in 1 hour. So here it's going 20 kilometers an hour. Here it's going 0 kilometers an hour. Here it's going 20 kilometers an hour. Here it's going 0. Here it's going 20 kilometers an hour. Here it's going 0. And from here it's going from 60 to 100, so that's 40 divided by 4 hours, from 6 to 10. Here it's actually only going 10 kilometers an hour. Okay? So it's going different speeds at different times, but the average for the whole trip, you take the beginning and the end, so 100 kilometers divided by the total time, 10 hours, so it's actually going 10 kilometers per hour for the whole trip. What is the highest speed it reaches? Well, we said here was 20, here was 20, here was 20, this was 10, and these flat lines were 0. So the highest speed it goes on the trip at any particular time is 20 kilometers per hour. Again, velocity is distance divided by time, or it's the slope of the line. And those are our answers. It shows you 100 kilometers divided by 10 hours is 10 kilometers per hour. 20 divided by 1 is 20 kilometers per hour. So again, the velocity of the object is the slope between 2 points. Rise over run. You guys have done slope with Mills, I know, probably for 2 years now, but that's how you figure out the velocity. It's rise over run. So now we're going to talk about velocity time graphs. A velocity time graph shows you the velocity, not the position, but the velocity of an object at a particular time. It shows you how fast the object is moving at a particular time. You can have positive or negative velocity. You have positive velocity if the object is moving away from the origin. You have negative velocity if the object is moving back towards the origin, where it started from. And if you look at the slope of one of these graphs, you can see if an object is accelerating, speeding up, or if it's decelerating, slowing down. So again, here is a velocity time graph. Here are our rules. We're going to look at the last rule first. First, you have to make sure you're actually looking at a velocity time graph. So to make sure you look at the labels, on the left-hand side, it should have something about velocity, meters per second, miles per second, miles per hour, something about velocity. On the bottom, it should have something about time, so seconds, hours, minutes. If you have that, then you know you have a velocity time graph. So that took care of rule 6. Okay. Now we're going to look at the others. Make sure you get these rules written down. They are important. You're going to need them, especially when you do problems in class. If the graph is going up, then that means that this object is speeding up. Okay? So from here to A to B, the object is speeding up. From C to D, the object is speeding up. From G to H, the graph is going up. That means the object is speeding up. If the graph is going down, it means that the object is slowing down. So here, for instance, from E to F, the graph is going down. That means the object is slowing down. Again, this does not mean that the object is going up and down. This is velocity. Going up means it's speeding up. Going down means it's slowing down. Okay? If the graph on a velocity time graph, it goes straight across, it means that this object is going a constant velocity or the same speed all the way across. So between B and C, this object is going the same speed. It's going 20 meters per second between B and C. It's the same speed. It does not mean that the object is standing still. It means it's going the same speed. Between D and E, the object is going the same speed. It's going 40 meters per second. Between F and G, it's going the same speed again. It's going 20 meters per second. Okay, so if it's going straight across, it means it's got a constant velocity or it's going the same speed. Now the slope of a velocity time graph will tell you if an object is accelerating or speeding up, or if it's decelerating or slowing down. So for instance, between A and B, the slope is going to be 20 divided by 2, which is 10. 10 meters per second, or 10 meters per second squared. Okay? So that means this object is speeding up at a rate of 10 meters per second. So for every second that the object is traveling between A and B, it speeds up and it goes 10 more meters per second. If you think about it, that makes sense because between 0 and 1, it goes from 0 to 10, and then from 1 to 2, it goes from 10 to 20. So each second, it's going 10 meters per second faster. Okay? Here, between B and C, the slope is 0. That means the object is not speeding up and it's not slowing down. It's going a constant velocity or a constant speed. And then if you come over here between E and F, the object is slowing down because the graph is going down. And that makes sense because the slope is negative. You're going from 40 to 20, so you've got negative 20. 20 minus 40 is negative 20 meters per second, divided by the time, which again is 2 seconds. So you've got negative 10 meters per second. You've got a negative slope, so you're slowing down. That means for every second that this object is traveling between E and F, it's slowing down by 10 meters per second. Again, that makes sense because at 8 seconds it's going 40. Now at 9 seconds it's only going 30. And at 10 seconds it's only going 20 meters per second. So it's slowing down. Okay? So again, the slope of a velocity time graph tells you how much the object is speeding up or slowing down. It's accelerating or decelerating. Finally, you're probably not going to need this last one much, but it is a rule I figure I'd tell you about. The area underneath of this graph tells you how far this object has traveled. So if we took and calculated, I'm not going to do it right now because this is a weird graph, but if we calculated all of this area under here, it would tell you how far this object traveled. So again, on a velocity time graph goes up, object is speeding up. Graph goes down, object is slowing down. Graph goes straight across, the object is going a constant speed. And if you take the slope between 2 points, that tells you how fast it's speeding up or slowing down.